Hi and welcome to this video where we're going to look at the 2019 probability and statistics exam questions. So the two questions we're going to look at are both from the 2019 paper 2. The first one is a section A, question 6, that's the probability question, and then the second one is a section B and it's question 8, and that is a statistics question, mostly an inferential statistics question. So let's jump straight into the probability question. Two independent events, F and S, are represented in the Venn diagram as shown below. The probability of F less S is 1 over 4. The probability of F intersection S is 1 in 5. And the probability of S less F is X, and all of those three pieces are given on the Venn diagram. So when we talk about that less, basically it's set difference, which means a takeaway. So F but take away S is 1 in 4. What we would talk about that in terms of sets is where that it is F only, not where F and S. So then they've given us an extra piece of information that's also on the diagram, and that is the probability of F union S complement is Y. So they have given us absolutely everything here. The only thing that they've given us that is not on the diagram that's going to be hugely important is the idea of independence. Obviously, they can't show that on the diagram, but you should know that the probability of A multiplied by the probability of B is equal to the probability of A intersection B if A and B are independent. So putting that in terms of this question, the probability of F multiplied by the probability of S should equal to the probability of F intersection S. Now, probability of F is everything in the circle. So that's a quarter plus a fifth. It is not just the piece that is a quarter. And if I multiply that by S, which is a fifth plus X, we should get, because we know they're independent, 1 over 5. So let's add those together. This goes to 9 over 20. And we're going to multiply that by a fifth plus X. Nothing great works, but if you want to do 1 plus 5x over 5, that is perfect. And that's equal to 1 over 5. So we need to do a little bit of work with the multiplication. How you multiply a fraction is multiply across the top and across the bottom. So we get something that looks like this, and that equals to 1 over 5. At this point, you can work whatever way you prefer. If you want to think of it as multiplying both sides by the denominators, you can, if you prefer, cancel off those 5s. Multiply both sides by 5s, they will cancel, and bring the 20 over and multiply both sides by 20. We get 9 plus 45x equals 20. So 45x equals 20. I've lost my 5, so it should be 45x. Go again. 45x is equal to 20 minus x, minus 9, which is 45x, is equal to 11, so x is equal to 11 over 45. So that's our value of x. Now, I would always say fraction form if you can. I wouldn't change it to decimal unless they specified it. If you've changed it to decimal, it's approximately 0.24-ish, but I wouldn't be encouraging that. Now, that's my x. In order to find my y, and I'm going to put this on my diagram now, 45. In order to get my y, I can use the idea that all my probabilities should add to 1. So I'm going to work underneath here. So I have a quarter plus a fifth plus 11 over 45 plus the value of y, and that should all add to give 1. I know that because It's in this universal set, that square box, and all the probabilities there should always add to 1. That will effectively give me 1 minus, and you can put all these together, you can work them out whatever way you want to do it, and we end up 4y as 11 over 36. Again, if you really feel strongly about decimals, that's about 0.31, but again, I would strongly recommend just sticking to the top heavy fractions unless they specify otherwise. So part B, in a club there are German, Irish and Spanish children only. There are 10 Spanish children. So we have 3 different sets of students. So what I would do at this point is set these up as German, Irish and Spanish. So there are, cardinal number of Spanish students, there are 10. There's twice as many Irish children as German children. So what we can say is the cardinal number of German children is some unknown. I'm going to say X. Therefore, Ireland has twice as many children, so Ireland has 2X. They're all waiting in a group to get on a swing. One child will be selected at random to go first and will not rejoin the group. The second child will be selected at random to go next. The probability that the first child will be German and that the second child will not be German is 1 over 6. Okay, so what we're saying is the probability that the first child is German and the probability that the second child is not German. So we often use this like flat bar to say not. It just makes our notation a little bit easier. When we do that, it should be a 6. So the probability of this child being German is X all over X plus 2X plus 10. The probability of the child not being German is Irish or Spanish, so 2X plus 10 all over X plus 2X plus 10, but the last child was not replaced, so we also need to take away a 1, and that should be equal to 1 over 6. So what we end up with is, on the top line, X times 2X plus 10. Bottom line, X, sorry, I'll actually clean that up as we go. So X plus 2X is 3X plus 10 and 3X plus 9. And that should all equal a 6. Now, multiplying by the denominators, we'll get 6 times X times 2X plus 10 on that side, and that equals 3X plus 10 by 3X plus 9. So we can multiply all this out. We get 6X by 2X, that's 12X squared. 6X by 10 is plus 60X. Working with these two brackets, we're going to get 3 by 3 is 9x squared plus 27x plus 30x plus 90. So just clean this up, sorry, a little bit, plus 90. Little bit of clean up on that, bring the 9x over. We get 3x squared. 60x minus the combined 27 and 30. That's 57. So when that's brought over, it's a minus 57. So that's a plus 3x. And then a negative 90. And that all equals 0. So we have a quadratic. So I'm going to divide across by 3 just to simplify the quadratic. And we get x squared plus x minus 30 equals 0. So guide number or minus b. If you're going to use guide number, we should be able to come up with the brackets to here. And it's going to be plus 6 or minus 5. So the answer is x equals minus 6. Our x equals 5. Now remember, x represented the number of German students. It cannot be 6. Therefore my answer is x equals 5. So they didn't ask that, they asked how many kids in total. So let's go back up here. So there were 5 Germans, 10 Irish, and 10 Spanish. Therefore, there will be a total of 25 students. So now let's take a look at question 8. So this is a section B question. It is a 45 marker and it was a longer inferential statistics question that appeared on the paper. So a motoring magazine collected data on cars on a particular stretch of road. Certain details on 800 cars were recorded. So straight away they've numbered how many cars we're working with. So we're talking about a sample. So 800 cars. If we talk about how many things are in the sample, that will tell us N. The ages of the 800 cars were recorded. 174 of them were new, so less than 1 year old. Find the, and this is going to be important, get my highlighter, 95% confidence, sorry now, the 95% confidence interval for the proportion. Now, that's important. At a higher level, we have 2 different confidence intervals we need to work with. We have the confidence interval of the mean, and we also have the confidence interval of the proportion. Both can be built quite similarly, but you do need to know the difference. So first thing I'm going to do is I'm going to come up with my formula. In order to help you with your formula, I would suggest, rather than learning it off, because that tends to cause problems for students, they learn it incorrectly, that you use your log tables. So statistics really starts from page 33, and the inferential statistics, we're going to start on page 34. So what we say is, when we have a sample, we end up with a sample proportion. So our sample proportion is p hat. We're talking about a 95% confidence interval. So we plus and minus 1.96. 1.96 is the z-score that is associated with 95%. And then we use the standard error of the proportion. So that's at the bottom of page 34. Now we do one slight variation to it. We call it p hat instead because that's what we have, rather than p. So that is our formula. Showing it in full, it's going to be p hat, smallest one first, so we're going to subtract first 1.96, square root of p hat 1 minus p hat all over n is less than or equal to p, the proportion, less than or equal to p hat plus 1.96. And again, we're working standard error of the mean. So that's p hat bracket 1 minus p hat. Just get rid of this little piece here. It's in my way. Over n. So things that I need, n, I know n, and the next thing is p hat. The thing about p hat, the proportion of the sample, they haven't never given it to us in the question. It's always been something that we've had to calculate. So our p hat in this question, like before, is something we calculate. 174 out of 800. That is the proportion. Working that as a decimal, which I'm not a huge fan of, but it does give us an even decimal, so we may find it easier for entering it into the calculator. So I go to my formula, so I get 0.2175 minus 1.96 square root of 0.2175 times 1 minus 0.2175 all over n, which is 800. So that gives us one side. It's less than or equal to p, less than or equal to, I'm going to move down here for a little bit more room. P hat 0.2175 plus 1.96, and it's the exact same margin of error. Sorry, it's the exact same standard error of the proportion that we're using on both sides. So you can calculate that and then use your answer button or other number holding buttons to help you make this question a little bit more efficient. When that goes into the calculator on both sides, you get 0.1889 is less than or equal to p is less than or equal to 0.2175. 2461. That's absolutely perfect. They asked it for significant figures. That's what it is. Personally, I prefer percentages, especially when we're talking proportion. I feel that I get a better grasp of what's going on, and I think for students as well. So if you do, you can change it to decimal, but you will get your marks regardless.
Part 2. The data on the speeds of these 800 vehicles is normally distributed with an average speed of 87.3 kilometers per hour and a standard deviation of 12 kilometers per hour. What proportion of cars on this stretch of road would you expect to find traveling over 75 kilometers per hour? Now, this might throw students because of the talk of 800, you think we're in the sample, but because they're talking about these 800 being normally distributed, we're going to treat this like the actual mean. So we have the mean here as 87.3 kilometers, and the standard deviation is 12 kilometers per hour. And what we're trying to find the probability that the speed is over 95 kilometers per hour. Remember, when we talk about what proportion of cars, that is another way of asking what is the probability. If you think about a really simple scenario of marbles in a bag, there's so many red marbles, so many black marbles, and you're asked what's the probability of red marbles, that is the exact same question of what is the fraction of red marbles, what is the proportion of red marbles. So when you see the word proportion, although it does mean something different as it's shown in the previous part, we talk about proportion as the same as probability in cases like this. So I can't work with X. I want to change it to a Z-score. So what I'm going to do, I'm going to take my X is 95. I'm going to go to my log tables and get my formula. It's the standardizing formula on page 34. It basically takes the values we have and turns it into a Z-score. Remember, a Z-score is a way of standardizing our information. It makes it so that it's all the same, and then we can use our log tables. We have 95 minus 87.3, all divided by 12. Your log tables will only use two decimal places, so round all your Z-scores to two decimal places. So there's my new Z-score. So instead of the probability that X is greater than 95, we're actually finding the probability that Z is greater than 0.65. Now, when we go to do this, you need to go to your log tables again, and we're looking at the Z-score page, or page 36. Now, if we're in page 36, the diagram at the top shows us that if we have a Z-score, we're working towards the left, or there's a little piece at the top that says the probability that Z is less than or equal to Z. We have a greater than, so we can't read it straight from the tables. I'm going to draw a little sketch. I think sketch is the easiest way we can do this. We're trying to find, apologies, I've written 65. This should be 64. So I'm going to put in my 0.64, which is about here. And I'm trying to find greater than that. So I'm trying to find this piece here. Now, in my log tables, the log tables only work to the left of the Z-score. So it's going to find that yellow piece there. And we're going to use the fact that all of the probabilities under this curve will add to 1. So I'll be able to say that, that this part here, which is the probability that Z is greater than 0.64, and this part here is the probability that Z is less than or equal to 0.64. When they're added together, it should be 1. Therefore, if I want to work out the bit that I have in blue here, it's going to be 1 minus the probability that Z is less than or equal to 0.64. Going to your log tables, that's 1 minus 0.7389. So I'm looking that up. It's on page 36. I go to 0.6 and then across to 0.04, which is 0.389. And that is 0.2611. And again, putting that into percentage form, the proportion of cars that you would expect to find traveling over 95 kilometers per hour is about 26.11%. So part 3, the driver of a car is told that 70% of the speeds recorded were higher than his speed. Find the speed at which the driver was recorded. Give your answer correct to the nearest whole number. Students find these questions very difficult, and that's completely understandable because of the way they're presented. But my advice on this is always draw it out. So I'm going to start here, and I'm told that the driver was told that 70% of the speeds recorded were higher than his. So I'm going to my diagram, and I'm saying he must be somewhere here. That's my driver. I'm going to say that this is a minus Z. My Z score in the table, they start at 0.01. So they start at that middle band. So that is kind of my 0 point. To the left will be negative, to the right will be positive. I'm looking for more than half, so this part here I'm saying is about 70%. Now this is only a sketch for me to get my head around it. Now I can't go to the log tables because the log tables don't have negative sets, they only have positive. So I'm going to work with a second diagram, and what I'm going to say is, well, if we work with the negative, it's actually completely symmetrical, so this will match if I do something like this. So this probability, or this area to the left of this new line, should equal that to the right. So let's say that this is 70%. The area will be the same. Now what I've done is I've actually created a positive Z which mirrors the negative Z. So I can go to my log tables and look up in the body of the table 70%. So I'm looking for 0.7. Now, the closest I can get to here is 0.6985. It's on page 36, and it's for the Z score 0.52. So I'm basically going to say that this is 0.52. This allows me then to figure out, well, the mirroring negative Z will be minus 0.52. So that's looking it up in your tables. Just be careful. That's about 0.0015 off 7, or 0.7. The other one is the ends in 19, so just slightly more. I will never do anything clever with regard scaling it down. You just want to find the one that's closest. So basically what I figured out is my Z score is minus 0.57. So if I talk about the formula as we used it in the last part of the question, I'm saying I know my Z score is minus 0.52. I'm looking for X. I know the mean is still 87.3. My standard deviation is 12. Working that through, I get 12 times negative 0.52 is equal to X minus 87.3. And that gives us X equals about 81.06, and they said correct the nearest whole number, and it's about 81 kilometers per hour. So that is the speed that this driver is doing. So part B then, a road safety program is carried out in the area using posters, signs, and radio slots. After the program, the motoring magazine recorded the speeds of 100 passing cars. The magazine carried out a hypothesis test at a 5% level of significance to determine when the average speed had changed. So that's what they decided. Now, remember we say that the null hypothesis is always going to be the average speed equals. The alternative hypothesis is the average speed does not equal. So they've determined whether the average speed has changed. So this is what their suggestion or their claim is. So they're claiming the alternative hypothesis in this case. The p-value of the test was 0.24. What can the magazine conclude based on the p-value? And give an answer. Give a reason for your answer. So the conclusion, they asked for two parts here. So the conclusion based off this is that the average speeds have changed. So average speed had changed. And the logic for that is, like if we think of this in our terms of our hypothesis, H0 and H1, mu equals mu does not equal. So the old mu that we were working with was 87.3. and the null hypothesis will be mu equals 87.3. The alternative hypothesis mu does not equal 87. And this, in terms of what we're asking, is speeds stay the same, while average speed and speed changed. And how we decide which one is correct, so our accepting or fail to rejecting and our rejecting, we talk about our p-values. So the p-value is 0.024, which is 0.24%. No, apologies, it is 2.4%. 2.4%. And because that is less than 5%, we fail to accept the null hypothesis. And if we fail to accept the null hypothesis, we are accepting instead the alternative hypothesis. In our case, the same, this have, and that's how we would come up with our answer. So this is the one which we're saying yes. So their claim would be correct. So the magazine found that the average speed of this sample was lower than a previously established average speed of 87.3 kilometers per hour. Find the average speed of the cars in this sample, correct to one decimal place. So this is quite a difficult question because we're working backwards from our p-value. So p-value is something students struggle with. And what I've done is I've just linked in the description below a really nice little piece about p-value and might give a better sense of what it is. Sometimes students really struggle with the concepts. So it's a nice little video, not mine. It's an extract from a documentary. You might find it useful. Let's break this down. If we're talking about the p-value, how do you calculate it? It's 2 times 1 minus the probability that z is less than or equal to z. So what does that mean? Well, I know that all of this is going to give 0.024. So my 1 minus p z less than or equal to z is going to be 0.012. Working that backwards, the probability that z is less than or equal to z is 0.988. Going to my tables, I can then figure out my z-score. 0.988, and we have 881, so 2.26. Okay, so that is our 2.26. But now, so this is where there's an extra level of trickiness. They told us that it was lower. So we have two scenarios here. We have the scenario, that's my very bad drawing, apologies, and we have the scenario where it's 2.26, but that would be higher than the average. So we're actually going to talk about minus 2.26. Both of them will give the same p-values, but we're talking about this tail here rather than the upper tail because we know that it's lower. So we're actually saying that's a minus 2.26. So now we go and we set up a standardizing formula, but this time it's a little bit different because we are talking about a sample. So our sample formula looks something like our standardizing formula, but it includes the n for the number in the sample. So it's the one sample z test at the top of page 35. So we have z is equal to x bar minus mu all over sigma over root n. X bar is the thing we're looking for. Minus 2.26 is equal to x bar, that's the thing we don't know, minus 87.3 all over 12 square root of 100. And when we work that out, x bar is 84.588, but they wanted it to one decimal place, so 84.6 kilometers per hour. So That p-value was asked in a very different way than we've seen before. It was working backwards, so students had to have a very good understanding of how they worked through it. If you knew how you worked through it to get your p-values, you could then step backwards. And some other things, I don't mind using z is less than or equal to z, but some students prefer to maybe turn that into like an x. So that's a little bit clearer to work with. So that z is less than or equal to some number x, and x is the thing you're looking for. Like I said, video link below for the p-values, and I'll also link the full inferential statistics module video, which may be of help.